Assalamualaikum and hello everyone. In this video, we are going to show you the application of linear algebra in electrical circuit. Perhaps one of the most apparent uses of linear algebra is that which is used in electrical engineering, as most students of mathematics have encountered. When the subject of system of equations is introduced, math class is temporarily converted into a crash course in electrical components. There, the resistor, voltage source, and capacitor take the stage, as well as their accompanying language consisting of Kirchhoff and Ohm. With the basic concepts down, math class is resumed, and students can look forward to playing with n number of equations with n number of unknowns. To solve for the currents and voltages, students can use simplification and substitutions, but with many equations, this task quickly becomes very time-consuming and tedious. In electrical circuit, Ohm's law is associated to conduct the current, resistance, and the voltage flow in the circuit. For our case study, we are required to determine the current in the given electric circuit with the battery and resistance component are given. To solve our problem, we use Cramer's rule method in linear algebra with the system of linear equation.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Muhammad ADLI bin AZRENKEFLY. Today, I will continue the presentation with the objective of the study. The first one is to form system linear equation based on the problem that we had faced in the electrical circuit. The second one is to be able to form matrix form after we had determined the system linear equation. The third one is to solve the question using one of the methods that we had learned, which is Cramer rule. The fourth one is to be able to find the value of determinant by using the Cramer rule. And the last objective of this study that we had choose is to find the amount of current that flowing in each circuit. That's all for the objective of the study. Bismillahirrahmanirrahim. We continue with methodology. In our case study, which is we are choosing the electrical circuit, we will using one of the solution of system linear equation, which is Cramer rule. We use Cramer rule because in our problem there are three unknowns, which are I for current, R for volt, and V for voltage. Thus, the matrix that we get is a square matrix. Therefore, it is suitable to use Cramer rule, which is Cramer rule is an explicit formula for the solution of a system linear equation with as many equations as unknown. And Cramer rule only valid whenever the system has unique solution only, which is the determinant of A not equal to 0. The first step to solve the problem that we get in this electrical circuit is to convert the problem into the system linear equation form, which is the first step that we had learned to solve the problem. After we had find the system linear equation form, we will convert it into the matrix form AX equal to B. After that, by using the Cramer rule, which is the solution that we had choose, we will find the determinant of matrix A. Finally, we can find the total current in circuit 1, circuit 2, and circuit 3 by using the value of determinant that we get by using the Cramer rule. That's all for the methodology. Thank you.
Assalamualaikum and hi, I am AHMAD bin DAUD, and now I'm going to solve our question, which is to find out the amount of current that flowing in each circuit. Okay, first of all, we need to convert the circuit into a system linear equation. We can see the right table is the circuit that we need to convert to the system equation to find the current for each loop. Okay, we can see that the current of first loop is I1, and then the current of second loops is I2, and then lastly is the current of third loops is I3. We also know the formula to find the voltage is R times I equal to V, which is I is for current, however R is for rho, and V is for voltage. The current of this circuit is actually move clockwise, and then we will get the first loop equation is 11 I1 minus 3 I2 equals to 30 V. Actually 11 means total of currents in loop 1. However, negative 3 means the current in loop 1 and also loop 2. And then 30 means total of voltage in loop 1. And then for second loop is negative 3 I1 plus 6 I2 minus I3 equal to 5V. Okay, negative 3 here means the current is loop 1 and also loop 2. However, 6 means total of current in loop 2. And negative 1 actually means the current in loop 2 and also loop 3. And then 5 actually means total of voltage in loop 2. And then the third loop is negative I2 plus 3 I3 equal to negative 25 voltage. Okay, actually negative 1 means the current in loop 2 and also loop 3. And then 3 means total of currents in loop 3. And then negative 25 means total of voltage in loop 3. And then we convert this all number into the matrix form, which is AX equal to B. We can see the first row, which is from the left to the right, which is 11, negative 3, 0, and also 30. This is actually for loop 1. And the second row is a loop 2. And the third row is actually loop 3. However, the columns is from 11, negative 3, and also 0 is actually I1. And column 2 is actually I2. And column 3 is I3. And the last column is voltage. Next, we calculate the determinant of matrix by using Cramer's rules. We also know that the formula determinant for 3 times 3 is just like the right table, right? Which is determinant A is equal matrix A, B, C, D, E, F, G, H, I equal to A times matrix E, F, H, I. We can see that is from like a right table, and then minus by B times matrix D, F, G, I. We also can see like a right table how to get a matrix D, F, G, I, and then plus C times matrix D, E, G, H. We also can see like a right table, and then we just apply this formula into our case, which is A is now is 11, B is negative 3, C is 0, and until 3 is I for the determinant A. And then in determinant A also, we just calculate just a normal determinant, and then we will get the answer is 160. However, in determinant A1, it just like same like determinant A, but the difference is just switch the column 1, the voltage column into the column 1, which is 35 and also negative 25. And now in this case, A is a 30, D is a 5, and G is negative 25. We just apply into this formula or determinant formula, and then we will get the answer is 480. And determinant for A2 is just like a determinant A and also A1, but the difference is the voltage columns is switched into the column number 2, which is the B is a 30 right now, and E is 5, and H is a negative 25. And then we just calculate just like a formula determinant, just like a right table. And then we will get the answer is 160. And then the last determinant always we also know as determinant A3. It just similar like determinant A1 and also A2. But in this case, we just switch the voltage column into the last column, which is C is a 30, F is a 5, and negative 25 is a I right now. And then we just calculate using formula determinant, and then we will get negative 1280. And then we also know the formula for Cramer rules is determinant A1 divided by A, which is 480 divided by 160. And then we will get 3 for I1. However, I2 is equal determinant A2 divided by A, and then we will get 1 for I2. And then lastly is I3, which is determinant A3 divided by A, determinant A, and then we will get the answer is negative 8. We convert this number into the perfect matrix, which is I1 is equal 3, and then I2 is equal 1, and I3 is equal negative 8. So the current flowing in the circuit is 3 for the first current, while for the second current it is actually 1, and the last current is negative 8. Actually, this is because the current is inversely proportional to the resistance. So when the resistance value is high, then the current value is decreased. So that's all for me. Thank you.
In conclusion, we can conclude that the current flow in the circuit is 3 ampere for the first current, while for the second current is 1 ampere, and the last current is negative 8. This is because the current is inversely proportional to the resistance. It means that when the resistance value is high, then the current value decreases. Thus, we can say that each loop has a specific current, which is the first loop has a current of 3 ampere, while the second loop is 1, and the last loop has a current of negative 8. Therefore, the higher the current, the more the voltage, and the higher the resistance, the lower the current flows. It is very clear that everything that happens in our daily life will involve matrix. For example, in a traffic law, balancing chemical equations, cryptography, and others with a certain formula. That's all from our group. Thank you. Bye bye.